Okay, so here comes in one of those problems that we get a lot, and it all comes into kind of how we're going to say what exactly we're talking about. So what do the zeros of a polynomial tell us? And we could also, a lot of times we call them the roots, we call them the solutions, and a lot of times in math we ask for the same thing, but we name it something differently. So it's really important for us to understand exactly what I'm talking about or what we're asking, even though we might be asking the same thing. So what do the zeros of the polynomial function tell us? So remember the zeros, same thing as our solutions, same thing as our roots. Let's just take a look at a function here. Okay? So let's say we have something that we're going to factor. And actually, you know what? Let me pick something a little bit easier here. Let's take a look at, actually, oh man, I don't know. I don't know what this is going to be. I'm just going to pick something. Let's have x squared minus 5x, and let's do plus 6. Okay? So let's say I want to decide, let's say my function f of x is here, right? And if I wanted to find the zeros, right, remember we say f of x equals 0. Because we want to find, here's your f of x, no, I'm sorry. Here's your f of x, and here's your x. So when f of x equals 0, we want to know when that graph crosses when f of x is equal to 0. At this point, f of x equals 0. So we plug 0 in for f of x, and what we do is we factor it, right? We try to set this up into two factors. Why do we want to factor it? Because there's a property we want to use, which is called the zero product property. But we factor this, and we get x minus 3. This isn't the problem I wanted to use, but whatever. X minus 3 and then x minus 2. All right? This graph does not use, I'm just making this stuff up. This graph does not resemble this equation. So anyways, we get these to these two factors. We call them factors because both of these multiply to give us this polynomial. So therefore, x minus a is a factor of f of x. Then the next thing we do to find the zeros is we set these equal to 0. So we say x minus 3 equals 0. And x minus 2 equals 0. So you could say x equals 2 and x equals 3 and x equals 2. Obviously, that does not resemble the same graph. But what you notice is by solving for it, x equals a is my 3 and my 2 for this problem. X equals a is a solution to f of x equals 0, meaning it is a solution to when I put 0 in for f of x. Because that's what you solve for. Because if you plug in a 3 or a 2 into this function, you're going to get 0 for f of x. So x equals a is a solution. Therefore, if it's a solution, then it is a 0 of the function. All right? Also, these are your factors. That's your solution. These are also your x-intercepts. So what we can do is we can write them in x-intercepts. Remember, they resemble the x value of it. X value, so you write 3, 0 and 2, 0. And there you go, ladies and gentlemen. That is how the zeros of a function are all related. I hope you enjoyed.